right, so today we have Andrew Rabinovich, CTO and head of AI at Upwork, which I'm sure many of you know about, but just in case, their tagline is connecting clients in need of freelancers who deliver. So with that, Andrew, welcome to the podcast.
Nice to meet you, Ben, and a pleasure to be here.
So I think maybe before we dive deep into AI trends and what you folks are doing in AI, give us a high-level overview of what AI in Upwork is for people who don't necessarily use your service.
Absolutely.
So what are the kind of like the manifestations?
Sure. I'll start with a bit of a background story. So Upwork is a marketplace of digital work that's been around for a very long time. And the traditional premise of the marketplace is that clients come to the platform to find freelancers to help them complete the tasks that they want to complete. And on the flip side of the bidirectional marketplace are freelancers looking for digital work. Once Upwork identifies the right freelancers for the right job, they match them, the contract is made, and then Upwork steps away, and then clients and freelancers collaborate with each other to get things done. About 18 months ago, when I joined Upwork, soon after we introduced Upwork's meta agent called UMA, stands for Upwork's Mindful AI, whose job is to facilitate the interactions between clients and freelancers. Initially, when the client comes to the platform, their goal is to make UMA understand what it is that they want to do. And then UMA needs to figure out whom it needs to recommend for hiring. And then the interaction happens, and then the freelancer gets introduced to the client. They initiate a contract and then move on. There are a number of steps that are involved in this process. And UMA helps both clients find the right freelancers and at the same time finds freelancers find work on the platform. That's sort of the status quo today, but we're extrapolating this beyond, and I'm happy to talk about that as well.
So it sounds like, so based on the high level, so this is based on what you just said, and I've kind of also read a little bit about some of the things you folks are working on through your blog. It seems like you have some of the things that many enterprises have, like you use multiple models, not just one. You use the pre-trained models from the big foundation model builders, but you also spend a bit of time fine-tuning and customizing models, small specialized models for different use cases. So one question, Andrew, do you guys also use things like RAG, retrieval augmented generation, and search, and variants of RAG, like what people call graph RAG?
Absolutely. So we do build our own internal models. They are extensions of open source foundation models, but we do two levels of fine-tuning. One level is to give UMA a personality, irrespective of the task. And then on top of it, if you can think of it as a mixture of experts type of model, where UMA has these skills. It has a skill of creating a job post from a conversation with a client. Then it has another skill of finding the right freelancer. Then yet another skill of helping freelancers write proposals for particular jobs for clients. And then in turn helps clients pick which of the freelancers based on their proposals to select for the job. On top of it, there are things like UMA's skill of question answering, and that requires absolutely having a RAG system, because otherwise it would be impossible to integrate all the dynamic and real-time information from the platform into the weights of the model.
So, so the skills, I assume you use some sort of routing model?
That's correct, yeah.
So it's so what about, so to what extent, I guess you have to also kind of weigh kind of the cost and latency. So some of the routing has to factor in, should I use a reasoning model or a simpler model?
So that's a great question. We typically don't rely on reasoning models for this problem of latency and huge delays, right? When clients interact with UMA, they have this expectation that things happen in fairly real time. There are parts around things like candidate evaluation or proposal writing that may include reasoning steps, but in our experience, we've seen that reasoning isn't all that necessary when performing such end-to-end tasks that you can train the model for explicitly. So we adopt this mindset of narrow AI. So UMA's skills, they're very, very good at these specific things that we fine tune them for. But if you ask it to, write you sonnets in Shakespearean style, it probably wouldn't do that well.
So when you folks use RAG, so you hit a system. So is the system how much structure is in the sources? So is there a knowledge graph, or is it just text plus metadata? What
Uh,
what exactly is being used in the backend?
So it's a good question. So we have a lot of information that is encapsulated in the knowledge graph, and then the knowledge graph points to different data sources. And these data sources live in a variety of databases, but the knowledge graph, on one hand, is able to route UMA to be able to figure out which RAG platform to grab things from, but also to draw inferences. For instance, if someone is looking for a front-end developer, then we can also identify that front-end development is associated with JavaScript or React. And this information comes from RAG. And then you can go and look for things that basically expand the query in classical search terms. This is called query expansion. And the knowledge graph allows you to do such query expansions so that multiple RAG systems are queried essentially to retrieve context for search.
So obviously for RAG, it's garbage in, garbage out, right? So there's a bit of data quality that you need to wrestle with and address. So in your folks' case, so what was the hardest thing in terms of tuning your RAG system? Was it the embeddings? Was it the chunking? Was it the re-ranking? Obviously, RAG should be viewed as a holistic system where you optimize these things end to end. But where do you feel, Andrew, you actually got the biggest bang for your buck?
So the biggest sort of benefit of Upwork is that it has tremendous amount of data, and this data has this concept of essentially self-curation, meaning that when matches and searches are performed, the fact that a client ends up signing a contract with a freelancer is basically a label on the fact that the particular search performance is correct. The amount of revenue that gets transacted on the platform also is a big labeling signal for that. So that gives us an opportunity to identify which data sources are more valuable than others on one hand. On the other hand, there's this sort of curse of dimensionality, sort of this classical concept in machine learning, but applied to data. We have so much data that sometimes it becomes sort of a problem in the sense that you don't know where to pay attention to because there's multiple sources and you have to pull them from different domains. I think it's a good problem to have because it gives us an opportunity to not just say we don't know, but we say we need to figure out where to get it from. And then the issues of chunking is a classical one. We have developed proprietary algorithms that do these sliding window style approaches to allow to forego constant chunk sizes.
And I assume
And
I assume
sure.
you have people who have expertise in information retrieval and search, right? Because I think one thing that people kind of underestimate is sure RAG. What RAG is you ultimately does is you provide additional context to the model, but obviously you have to provide the right context. So retrieval, search retrieval, search ranking, those all still matter.
100%. So Upwork has a very long history of search capabilities. In part, and it's again, it's a two-directional system. On one end, when clients look for freelancers, there is a search, ranking, and retrieval mechanism, and on the other end, there's sort of this discovery and recommendation systems. When a freelancer posts their profile saying I'm good at XYZ and I'd like to do ABC, and then without them going and like scrolling through lists and lists and lists of posted jobs, the recommendation system provides them with postings and saying you can work on project A or project B or project C. So yes, Upwork has a very deep bench in search capabilities that have been developed over many years. And over the last 18 months, they've been significantly upgraded to be state-of-the-art algorithms in both search and retrieval.
So you've hinted at this, and I think I may have read this somewhere in Upwork blog post, but the notion that digital work is a great tasting ground for AI agents.
Absolutely.
In the sense that, some people historically, when people think of agents in the kind of, I guess, almost distant past, people think of simulations and games. But now, I think I read somewhere in your writings that you folks feel that kind of this digital work environment is actually even better in many ways than
it is. So if you think about agentic work that started a while ago, almost 20 years, and I think of like self-driving cars as agents, they are primarily trained in simulation, right? They can only be trained in simulation because if you allow a Waymo car to learn from experience in the wild, then there's consequences that we don't want to talk about. At the same time, if you allow agents to learn from an environment that is realistic, relevant, relatively to their real world, then the results are really incredible, right? And I think if you think about AlphaGo, you see this. Although the machine was allowed to essentially play with itself in simulation, that simulation is no different from that machine's reality, right? It just a game of Go is the same in simulation versus real life. It's all the same, right? So if we can replicate that kind of transfer learning from simulation to the real world, then you can expect really, really unprecedented results. And digital work is the kind of domain where it is almost okay to make mistakes, so long that you can learn from them, right? If I ask you, for instance, to build me a website, and you're an agent, and you build a website that's completely orthogonal to all the human conventions of website building, and you present me a website that's like spherical and upside down and inverted colors and whatever, there's no real harm in trying to do that, as long as you get the feedback that this isn't good, or maybe it is good and it's something that's no one's ever thought of. The intuition behind this is that just like in AlphaGo, we had this move 37 aha moment. How do we get to that move 37 in sort of real world tasks? And considering that Upwork encapsulates all kinds of digital work, then there's an opportunity to be able to get to that move 37, with the exception that in AlphaGo or in games in general, the reward or the value function is predefined. In the real world, there are a class of deterministic problems like math and coding, but unfortunately, the rest of real life is not deterministic. So you need someone to provide value to the proposed solution. And that's where the dramatic benefit of Upwork comes in, because it's full of experts in any kind of digital work that can provide the value function and therefore the reward for these agents.
So in the Waymo case, in that scenario, you build a simulator or some sort of digital twin.
Mm-hmm.
In the AlphaGo case, it's self-play, so you just play against yourself or against another system,
Other machines, yeah.
other machines for on and on, right? So from zero to until you become an expert Go player. So in the digital work case, how do you do this equivalent of self-play without alienating too many users? You know what I mean?
Elaborate on the alienation part.
Well, if it's not like you can deploy this agent and expect it to learn in the wild, right?
No, you deploy this agent, and there are multiple ways of doing it. One way is to give a set of tasks to all agents who want to participate, essentially create a benchmark. And then agent perform particular tasks, and then their behavior gets, or their results get evaluated by human experts. And then you can think about how do you democratize all those learnings.
So this is the equivalent, Andrew, of in the AI alignment world of reinforcement learning from human feedback almost.
Kind of. The
I mean,
problem
the pipeline is similar.
the pipeline is somewhat similar. In the human reinforcement in RLHF world, humans come up with rankings of multiple results made by a machine. So a machine gets to only learn what the human feedback is, based on the tasks that are predefined. Here, you get the machine to propose any solution that it wants, and then a human only tells it if it's a good solution or not solution.
So just thumbs up, thumbs down.
Exactly. So in RLHF world, it's rank order between do you like A or do you like B, right? And then basically the knowledge that you extract from it is confined to basically human preference. Here you get to explore this very large landscape of possibility where the agent is really allowed to do whatever it wants, and all it does is gets a reward, just like in almost classical reinforcement learning. There are a lot of new ideas around how do these tasks that agents perform correlate to each other, and whether a solution to one of these tasks has to be consistent with a solution to another task. For instance, if you're a child that's learning to balance, balancing when you sit versus balancing when you walk versus balancing when you stand, it's all the same balancing, right? So the policy of learning to balance when you sit has to be tied to the policy of learning when you're walking or doing other things, right? So there's a connection that needs to be made across multiple solutions of different tasks, but otherwise the agent can basically do whatever it wants, and it just gets feedback from the environment of whether it's doing well or not by the reward that it observes.
So in this scenario, so you're trying to train an agent in this digital skills marketplace. So I guess what you do is you recruit certain human evaluators who are experts. So a bunch of people who are good at copywriting, a bunch of people who are good at building mock-ups or wireframes, a bunch of people who are good at building or coding up a website, and so on and so forth. So so by the way, what we're discussing here, is it theoretical or are you folks starting to build it?
It's in the works.
It's in the works. Okay. So then you're still in the process of finding out how big the sample is for this reinforcement learning step for each of these skills before you're comfortable saying, okay, so we've done enough in the wireframing area. This agent might be good enough for wireframing.
That's correct. As you know,
But that magic number in the variety of the tasks, you're still not that's still in the works and you're still exploring.
That's right. So as you know, one of the Achilles heels of reinforcement learning is that it requires a tremendous, exponentially more samples for learning than compared to traditional supervised learning, right?
Yeah, and I think our listeners who may be too young to remember, but before Transformers, right? So the path to AGI was all about RL, right? So through whatever AlphaGo, and then the games that OpenAI was playing, the video games, right? So
That's correct.
but then the thing that the DeepMind folks always said, if we just have enough compute, we can get anything done, right? So
if you have enough compute and if you have a rigorous value functions and transition policies, the problem is that we don't know how to evaluate behaviors of agents in non-deterministic domains, and therefore progress there is kind of slow. If you think, for example, how AlphaFold works, you allow the machine to create proteins. There's some constraints around what protein structures are not like chemically plausible, but then of the ones that are plausible, creates this like short list, and then human scientists go and take these proposed structures that they would never think of on their own, and then they go test them in a test tube or whatever, and then they come up with some useful outcome, like in drug discovery or virus control. So you want to be able to do essentially the same thing. One interesting, and this goes back to the example of balancing, in digital work, there is very, very strong regularization among tasks. And this ties back to some of the work that I've done in the past on multitask learning, and this idea of subproblems is that when you solve one task, the solution to this task has significant influence on another one, right? When you do things around like website design or graphic design in general, these things are correlated to each other. When you do machine translation versus creative writing, these things are also correlated with each other. So the way you define value functions and transition policies, these things are very much connected. Therefore, it will allow us to reduce the number of samples that are necessary, because if you're solving the problem in isolation, there's just not that many constraints. Similar to the game of Go versus chess, right? Chess has much more constraints, so the game becomes explicitly simpler than Go, because Go is so much more open-ended. Now, with regards to these human experts, coincidentally or not, Upwork is full of hundreds of thousands of experts in every domain of digital work. Therefore, these freelancers, they become experts in basically evaluating agents, and the whole mechanism is basically done through the platform itself, where rather than a client coming into the platform and saying, I want a particular job done, find me a freelancer to do the work, you can think of agents now being clients coming into the platform and saying, we have proposed a solution, we need a human evaluator to provide it. So then this matching happens again, and it proceeds forward.
So I don't know if you've been following. So it seems like this is a different strand of reinforcement learning from a relatively recent strand that's focused on LLMs, right? So there's these reinforcement learning libraries that focus on LLMs, particularly for RLHF or reasoning, reinforcement fine-tuning for reasoning models, and for some sort of multi-agent systems for sequential task completion. So this seems like more classic reinforcement learning, similar to what AlphaGo required. So in which case, so are you developing your own RL library, or are you using open source libraries like RLib?
We're building everything. I mean, we don't rebuild things that are not necessary, but this is a new style of reinforcement learning that we call reinforcement learning from experience, or RLEF. And what it ties into the LLM is basically a way to represent data between the agent and the environment, right? It's just a representation. It contains certain amount of pre-training that's necessary for the agent, so the agent doesn't have to learn from scratch. But all of these reinforcement learning findings from experience, they tie back to the LLM representations as well. So I think to be brief about this, it's a mix of classic RL ideas together with this RL plus LLM paradigm.
And none of the existing open source libraries quite fit what you need.
That's correct.
And so, wow, so you're building something from scratch.
I mean, I think it's a necessary step in this sort of, as you alluded to, path to AGI, because if we simply capture what's available in terms of human capability, then we're never going to be able to surpass it, and we're also always going to be at this human knowledge limit, which is what we need to break through in order to get this AGI or super intelligence.
So the idea here is that reinforcement learning, while it's harder to implement, harder to set up, and just harder to execute on, is ultimately gives you a much more powerful system than anything you can ever get from fine tuning, right? Because fine tuning just basically you're somewhat the capability of whatever you fine tune is somewhat directly tied to your fine tuning data.
You're absolutely right. The world is very complex, right?
Whereas reinforcement learning, the idea there is you'll get a model ultimately that will be a lot more capable, I guess.
Expressive.
Yeah.
Because when we fine tuning is gated by the imagination of the engineer, basically. Like whatever kind of things I can think of, I'll create examples. Even if we talk about synthetic data generation, right? When you create synthetic data, you still have to give parameters according to which the data is produced, right? If I don't know the smooth 37 dimension along which to synthesize the data, it will never be in my training set, meaning that if I fine-tune the model on this training set, it will still never know. So what we're trying to do is we're trying to create an environment where agents can go beyond human sort of imagination and do things that we either have never thought of or have thought of as completely the wrong directions to explore in, but the agent, since it can do it so the other thing is that we have to set it up in a way that it's fairly cheap, right? Because if explorations are exponentially expensive, then it's not the path forward. RLHF is kind of that, right? People, big companies, hire thousands and thousands of PhDs in science and math simply to label the solutions that the machines produced based on their pseudo hallucinations, right? And I don't think that's exactly the right way to move forward, because the space of explorations is enormously large. The world is very, very complicated. It is not well described by language, contrary to majority beliefs. And if we are going to make breakthroughs in beyond this limit of human knowledge, then we really need to allow machines to explore on their own, and then just help them understand whether they're making right decisions or not in the presence of the world model.
And what makes this tricky is obviously if the task is deterministic, the chances are the foundation model builders have built that into their model already, right? So for example, coding or math or something like that, right? So whereas in your
Exactly.
case, there's a bit of subjectiveness in terms of beauty is in the eyes of the beholder in terms of what's a good website or what's a good paragraph, right?
Absolutely. And I think that's kind of the interesting part about intelligence is that there are a lot of components of the world that we live in that are deterministic, but there's a lot of it that is completely dependent on context and the vanishing point. Um, Therefore, being able to describe everything in rules simplifies things too much and makes the world into this, video game like simulation that does not open up the capabilities to their fullest.
So where are you, Andrew, on this RL journey? So or uh, uh, how far along are you? So you're trying to build this library from scratch, and then you've kind of laid out what the pipeline will be, right? So
Mhm.
so what kinds of explorations have you done?
So this effort is fairly recent. We've been working on it for about 4 months, 4 or 5 months at this point. And the types of explorations involve, first of all, you need to create an environment where humans and machines can interact in a way that's understandable for both. And I'll give you an example. When we use things like ChatGPT or Claude or Gemini or whatever, the most interactions happen in a text prompt, right? You say, create me an image or a short video of an elephant flying through the world. It creates an image, and then, for example, in the image, you don't like the placement of the elephant, or you don't like its size or the shadow that it casts onto the world itself. It is very, very difficult for you to describe or to tune the prompt in such a way that the elephant would move or the shadows would be changed. Basically, the steerability of these models is very, very tricky. It's a little bit simpler with text. That's why we talk about prompt engineering so much. But when it comes to other modalities, it's basically impossible. If you look at the kinds of work people do on Upwork, more than 50% of the outcomes are in modalities outside of text. Meaning that when a machine creates a solution, a human needs to be able to evaluate the solution and then provide feedback to a machine that's understandable and actionable. Because if you just say, this is right and this is wrong, it's useful, but it's far less useful than if you explain what is actually wrong and how you can potentially improve it. So that's one bit. So you need to create this environment where the human can easily interpret the results from the machine, and the machine can easily interpret the feedback that the human provides.
So the output from the machine has a specific modality, right? So it could be text, it could be an image, video, or audio. And then
Correct.
can't you just say, okay, so what I don't like in the audio is from minute 140 to minute 152.
Correct. That's good. So that's kind of a localization feedback.
Yeah.
But then an intelligent agent would prompt back and say, what is it that you don't like?
And then you can explain. But
But
then
it's impossible to explain, right?
it might be impossible to explain. So let's say it's a song, right? So you go,
Exactly.
it doesn't quite work for me.
So you can, I mean, hopefully it can be a little bit more rigorous than that. You can say it's in the wrong key, or the tempo is wrong, or I don't like the instrument. But then you need to be able to kind of identify it and show it. Think of it as almost like Photoshop. You're given Mid-Journey generates you an image, and this image pops up inside Photoshop. And then in Photoshop, you can circle and say, this bit on the top right has the wrong saturation value. And this bit on the bottom left is too blurry or whatever. And then the machine takes those inputs and then it can augment itself or regenerate the output based on this feedback.
So you have to kind of innovate on the UX for this.
As well, yes.
Yeah.
Now, one interesting bit that has come around recently is the MCP protocol that allows data to be connected to agents. Given this human-machine interaction that we're pushing forward at Upwork, we extend MCP into a framework where you have data, machine, and human, and we call that up format, where the interactions between humans and machines and data is captured in this protocol so that it's both understandable by the machine and the human, and you're allowed this multi-turn interactions between humans and agents so that the agent can actually learn from the experience itself.
Huh, interesting. So let's see. So what about, I guess, an ongoing problem, even for simple AI applications, including agents, is eval, right?
Mm-hmm.
So I'm sure eval will be kind of a challenging question here too, right?
Absolutely. So initially, since I don't believe that agents have so-called agency to complete tasks end-to-end at sort of large extent. And there's been a lot of work from OpenAI and other places where they would take tasks from Upwork and ask agents to complete them. And it turns out the completion rate is very, very low. And the amount of work that these agents can do is like 30–40%, depending on the task itself. So initially, all of these evaluations will be done by humans. But then these evaluations become a set of training data for like LLM as a judge type of construct to learn from. And the question then becomes how much evaluation examples is enough for LLM as a judge that's specific to a certain category becomes confident enough that they can provide meaningful evaluations, right? Now, when it comes to the complexity of evaluating, it is strictly easier to evaluate an outcome of a particular task than to propose an outcome itself, right? This is this P and P kind of a thing, right? It's hard to solve hard problems, but it's easy to verify if the solution is correct or not, because you just run the machine and it tells you what's going on. So evaluation is a big issue. And in a lot of categories, depending on their complexity, we see that the role of a human sort of up levels from doing the actual work to verifying that the work is done correctly and or giving feedback back to the machine on how to improve themselves.
Actually, this discussion has just kind of opened my eyes in terms of the following, right? So I would never have thought of Upwork as the perfect setting for building kind of knowledge work agents, right? So real knowledge work agents that work. But then on the other hand, I guess for you folks, the temptation is to boil the ocean and solve everything. But maybe the right approach is to find some of the more popular tasks in Upwork and just focus on those for now, right?
That's correct. So one big caveat is that UMA, this mindful meta agent, if you will, is primarily focused on understanding what clients want to do and then finding relevant resources to get those jobs done. And those relevant resources will be humans and machines that can do the work. But the machines that will be exposed to the opportunity to do this are third-party agents. So think of them as apps in the App Store. The Apple made the
That
phone.
that Upwork doesn't necessarily build themselves.
Absolutely. As long as these agents pass the bar of quality on a per category basis, then it's fair play. Just like we have hundreds of thousands of human freelancers on the platform, we can have millions of agents that can do high quality work, so long that they qualify to be experts in what they're doing.
By the way, Andrew, are there agents now that are doing just that? That they already, for a certain status or skill, that they're already one of the more popular?
Not in the open domain.
Okay. So, but if it's super narrow, there's some agents that already are getting a lot of work.
We're at a very early stage. I can't really talk too much about this, but we're starting to see some very promising and interesting results where agents can be valuable.
So the RL work that you're doing, let's fast forward 5 years. Let's say it's in production. What would be the user experience for a user of Upwork?
So as we started at the beginning of the chat, a client comes in, tells Uma what they want to do. Then Uma identifies the right freelancer, they're matched, and then the freelancer does work for the client. If you fast forward, and hopefully it's less than 5 years, client comes into the platform, assuming it's a human client to begin with. They tell Uma what they would like to do, and then Uma just delivers them the result that they're looking for. That's it. So Ben comes in and says, I would like to build a new website for my podcasts, or I would like to build new software for creating podcasts. Then Uma has an conversation with you about the details of what you want to do, how much money you want to spend, how long would you like it to take, and after that time has elapses, Uma just delivers you the software that you're interested in, and that's it. What happens in the sort of the background is that Uma identifies the relevant humans and machines to do the work. It tells them exactly what each one needs to do, and it kind of orchestrates the work. Then the humans and machines interact. The machine does most of the manual work. The human does more of the high-level understanding and evaluation and guidance. And then together they produce an outcome that Uma delivers to the client.
Yeah, I think in the future, a lot of work might boil down to orchestration, right? So I mean,
Yes,
if you're a knowledge worker, you end up orchestrating a bunch of agents.
that's possible, or you start doing knowledge work in domains that we haven't thought of yet, right? So the way I think about intelligence in general kind of falls into three categories. The first category is formulating the problem, and arguably that's the hardest thing, all right? The second bit is doing the manual work of trying different combinations, trying different explorations, and that's this whole like agents in the wild type stuff. And the third bit is knowing when to stop. When does a machine provide a solution to an evaluator that says, yes, this satisfies the requirements, this is good enough, we're done, I can like ship it back to the client. So I think the first part and the last part of the problem, they're not going to go away ever. Everything is just going to become more sort of advanced, right? And the interesting bit is that we see this today when freelancers say that there's certain aspects of their work that they would love to farm out to machines because this is mechanical and redundant, and they would rather focus on something more high level and creative and not worry about this bit. If you sort of turn this back 20 years ago, and if you ask a freelancer to translate from French to German, the mere fact of translating, they would find it as interesting work. And then if you ask them, well, what if you had an oracle that would do it for you? Then would you be out of work? Today, we're seeing that the same translators or interpreters are saying, no, we want to be the editors and we want the mechanical part of the translation to be done by something else. So the same thing is going to happen in the future. If today a freelancer is building a website, then tomorrow with the sort of orchestration or help of other agents, it's the same freelancer will be able to build social networks, without having to spend millions and millions of dollars.
Huh, interesting. So in closing, Andrew, looking at Upwork today, so what kind of work do you think will agents be able to do, let's say in this next 6 to 12 months, that may surprise our listeners?
I think agents in the next 6 to 12 months, very similar types of things you'll be able to see on Upwork as you see it today. The big exception of that is that work will be delivered much faster and cheaper. I think if you extrapolate the examples of, say, Cursor or Lovable, things like that, Lovable doesn't create anything that hasn't existed before, right? It just allows you to do it with far fewer technical skills in much shorter amount of time. The problem with those systems is that they'll all end up producing very similar pieces of software because it's sampled from the same distribution, right? Here, with this RL expansions that we're working on, the goal is to have agents create concepts that are out of distribution, and then human experts evaluate them for quality and then provide them to the clients. So in a nutshell, we think that in the 6 to 12 months time span, the categories of work that people will be able to get results for at Upwork won't change dramatically, but the quality in terms of time to delivery and cost will be significantly reduced.
And that's a combination of both the tools that Upwork provides the users, both the users and the contractors, but also the contractors themselves might be using all sorts of AI powered tools to improve their productivity and quality.
That's correct, and they're starting to do this already, and they're all very excited about. Another aspect of work that we're considering is allowing freelancers on the platform to build their own agents. We call this second-party agents. So if you're a freelancer on the platform, you are either sort of skilled in using a variety of agents that exist in the marketplace, or you can create your own agents. So, and again, as long as
because you have so much domain knowledge and also marketplace knowledge, right?
Exactly, and as long as they qualify in this sort of evaluation protocol of being good enough, of high quality to be in the marketplace, then it just becomes an agent in the marketplace, and either the freelancer themselves or anyone else who is on the marketplace can have access to them as well.
So, final question. So, what would you like to see from the foundation models in the next year?
I would like the foundation models to become smaller and faster. I don't think that reasoning models are the solution, because as we've seen from some empirical results, that often the reasoning steps don't come to the correct answer. And the inverse of that, if you try to get to the correct answer without reasoning, you can do that as well. So there's a little bit of a disconnect there. But generally speaking, I don't think these models need to be so large. I think there's a tremendous amount of redundancy in them. And more importantly, I think they need to start encapsulating some more of this symbolic AI constructs into the world, where we're not just learning patterns in the data on the internet, but we start injecting, as we start seeing this with like math and coding, we should start injecting some notions of physics into, of the real world into these models.
It seems like the all the current foundation model builders are still betting that scaling laws will take them far, and then but on the other hand, they recognize that, we need smaller versions of this model. So they all have, Google has Gemma, right? So and things like that that can be deployed much more cost effectively. But as far as their most frontier models, it seems like scaling loss is still the big bet. No?
Yes and no, because I think as you
Well, no. I'm just saying. I'm not saying whether it's right or wrong. It's just observationally, it seems like that's still the direction that they're going.
I think that that's just an opportunistic thing, right? I don't think there's many options.
Yeah.
I mean, it's not like you can say, let's spend $1 trillion improving this model, or like think of something else that we can spend
A
like
completely new architecture. Supposedly Ilya and his new lab are climbing a different hill, but we don't know. Right?
as they should be. I mean,
Yeah.
Jan talks about different type of approaches. Rick Sutton talks about different methods as well with this oak architecture. I don't think that LLMs are path to AGI. I think what it does is it allows us for a very efficient way to interact with data. But beyond statistics, I don't think we'll get there in any way. Similar to how we worked with ConvNet in the past, we were able to provide a representation of how we go from sort of observation, perception to concepts. Same thing here, like these latent space embeddings don't create intelligence or don't create knowledge. It's just a way of organizing data. But beyond that, there must exist something else that makes inferences that we don't have otherwise.
And with that, thank you, Andrew.
Thank you. My pleasure.